Hi everyone, welcome back to chapter 13. This will be the last video of content for the class. Woo! We're all excited. So, in this video we're going to finish up with talking about categorization and concept learning as well as language in terms of comparative cognition. So, first we've got categorization and concept learning. So, perceptual concepts to study are the studies of higher level and abstract concepts. And that's because natural stimuli never occur the same way twice. But we don't want to treat each stimulus as independent. So fortunately, we don't have to. We can treat stimuli in a category type setting. Stimuli are not independent, isolated events. We can use our previous learning to know how to respond to novel stimuli. So category perception is how our brains call all ducks a duck. It's from a different textbook. So it allows us to recognize a person as the same individual, regardless as if we see them from the front to the back, in a different outfit than they wore another day. If someone gets a haircut, we can still use other aspects of that person to identify them as them. So in comparative cognition, we're interested in whether non-human species can learn this categorization and concept learning, including different abstract concepts. So we might use what we call stimulus equivalence training. So this encourages a generalized responding to a set of stimuli. So we'll have a plus and a minus. So plus would be, for instance, if I give you a bunch of pictures, then if it has a plus, then we'll say it fits in the category. A minus means it doesn't. So a great example would be here. So we can use these sets of pictures, which is actually from a study in 1976 by Hunstein et al. And he asked people which picture has trees in it. So if there's a tree in it, it gets a plus. If it doesn't, it gets a minus. So here, there's a tree. Here we've got a house, but there's a tree on the side. We can kind of see a tree here. Here, this is a vegetable. Vegetables are not trees. And then here, this is like granite, and a bunch of just squiggles, okay? So what aspects of the tree photographs led the pigeons to classify them differently than the non-tree photographs? So he was actually able to train pigeons to tell the difference between what has a tree and what doesn't. So a pigeon was able to tell that this vegetable here, I'm pretty sure it's celery, was not a tree. Kind of looks like a tree, but it's not. And a pigeon was able to tell a difference. Now, a pigeon was also able to see that there's part of a tree over here. So even though the main aspect was a house, the pigeon could see that there was part of a tree in it. So really, you know those online, like, prove you're not a robot things, verifications they make you do, where they're like, click every picture that has a fire hydrant in it. They do it to be like, prove you're not a robot. Well, it turns out a pigeon can do those types of things. So it's not just prove you're a human, it's just prove you're not a robot, because pigeons are just as smart. So in category learning, then we learn to classify what we call exemplars into these categories. So an exemplar would just be like a novel stimuli or some type of stimuli. Now, there's actually two different things that go on in category learning. We learn generalization, which means we put things into a category. So a bunch of things within a category, then we can generalize. And discrimination, which occurs between categories. So discrimination is the tendency for a behavior to occur in the presence of a certain stimuli, but in the absence of something else. Okay? So these are two very important characteristics. So generalization within category would be like all cats are cats. You can distinguish that's a cat, that's also a cat, that's also a cat. But then you discriminate between categories. So you know that's a cat, that's a dog. Cats and dogs are two different animals. So being able to tell the difference between, okay? So for example, chairs. Despite all their different structures and fabrics, we still are able to call things chairs, even though they look very different. Now, what about, or how do we do categorization? So here we've got two categories. We've got butterflies and we've got dogs, okay? So this is a previously set category within the blue of dogs. We know these dogs. In the blue on the left, we've got butterflies. These are butterflies we all know about. But what about novel stimuli? So for example, first we've got this butterfly up here, this animal. We don't know what it is, so you have to be able to categorize it. Is it a butterfly? Is it a dog? Well, it's similar. It's got two wings, it's got antenna, and it's fawn-colored. Probably a butterfly. Whereas here we've got our other animal. It's got fur, 4 legs, 2 eyes, a nose, happy tongue, probably a dog. So we're able to categorize it into a dog, okay? So this is how categorization works. You've got a pre-existing category in your mind, and then when you encounter a novel stimuli, you're able to categorize it into one of your pre-existing categories. Now, one thing that can be tricky is that we actually have these things called true categories versus pseudo categories. So a true category is something that we have in what we call experiments. In experiments, we have these. So a true category would be like a real category, so like butterflies versus dogs. So now when you encounter a brand new stimuli, like say this cartoon butterfly, you're able to easily place it into a category because we got all butterflies here, all dogs over here. So if you're training, say, a pigeon to peck pictures of butterflies versus dogs, it would be rewarded for butterflies and not rewarded for dogs. Very easy. It can do this easily. But sometimes we make these categories in experiments called pseudo-categories. And a pseudo-category is really just a made-up category. There's no defining feature. So here we've got half butterflies, half dogs are rewarded. And over here, we've got different butterflies and different dogs are not rewarded. So here you have to memorize each individual dog and each individual butterfly in category A versus the other different individual butterflies and different individual dogs in category B that's unrewarded. Now, why would we do this in an experiment? What we want to do is we need to be able to test, are the animals using categorization to place the novel stimuli, or are they using rote memorization? So rote memorization means that you're memorizing each individual rather than creating a category, okay? So if the animal, when we give them a new stimuli that they haven't seen before, if they're using rote memorization, then we wouldn't see a difference between pseudo category and true category because they wouldn't know where to put it. But if they're using categorization, then in the true category, they'd easily be able to put a dog here and a butterfly there. And in the pseudo category, they wouldn't know what to do because they'd never seen it before, so they don't know where it goes. Okay? So this is where we're looking at that generalization to a novel exemplar. So we're transferring our knowledge from the acquisition phase into the testing phase. So we're testing the transfer of performance to our stimuli that did not appear during training. So evidence of generalization to novel exemplars, critical for demonstration of perceptual concept learning. In other words, that they can learn categories. Now, I'm going to show you guys this study using chickadees. So this is a study from the lab I'm in. This was done by my supervisor, so before I was there, but it's very similar to the work I actually do. So let's see if I can get this to work, but this is a mountain chickadee, and this is what they sound like. Okay, and then this is a black-capped chickadee. Okay, so you can hear there's a difference, okay? And so both of these are what we call a chickadee call. So this is their namesake call. If we play this one again, you can kind of hear them say chickadee. Exactly, okay. And then this is just a sonogram of what it looks like. So this was the black-cap, and this is the mountain chickadee. You can see they kind of have different hats on. That's how you can tell the difference if you look at them. So what this study did in 2008 is they wanted to know, can black-capped chickadees or mountain chickadees, can they recognize the difference between a mountain chickadee call and a black-capped chickadee call? So we're going to play them both and see, can they categorize the two calls as being different. So they'll probably all classify them as chickadee calls, but can they classify them by species? Okay. So one alternate interpretation to categorization is that an individual uses memorization, so which we know animals are capable of. And so by using memorization, then they'd be able to solve a pseudo-category design. But if they don't use memorization, if they're using categorization, then we'll see a difference between the true and pseudo categories. Okay? So what happened here? So we have a true group. So this is the dots with the solid line here. The true groups, then they were told to respond to the black-capped chickadee, do not respond to the mountain chickadee. Okay, so there was a true categorization between the two, and they were able to learn that. Whereas the pseudo group had to discriminate by rote memorization. So they got rewarded for some mountain chickadee calls and some black-capped chickadee calls, and then they were not rewarded for some mountain chickadee calls and some black-capped calls. So if they were to properly do this, they would have to use rote memorization. So here we've got our discrimination ratio on the y-axis, and the higher the DR, then the more accurate they are. Okay, so the better they are at telling the difference between mountain chickadee and black-capped chickadee. Okay, and what we see is that the pseudo-category birds, they stay at about 50%. So that's about chance level of responding. Whereas the true category group, over time, they become better and better at telling the difference between a mountain chickadee and black-capped chickadee. Okay, so in all these cases, then the participants or subjects learn to respond similarly to similar stimuli belonging in a category, whereas those in the pseudo group did not. So what we see here is that the black-capped chickadees that we tested this on were able to categorize by species. Okay? And we verified that by seeing that the pseudo-category did not, that there is a difference between the pseudo-category and the true category. Okay? So if they're using rote memorization, then these lines would have been the same. But because they're not the same, that means that they're not using memorization, they're using categorization. So that's actually the kind of work I do, but with different types of stimuli. So a future theory would be that members of a category have a common feature. So there's something within the feature, so perhaps within a mountain chickadee call that makes it a mountain chickadee call, and there's something within a black-capped call that makes it a black-capped call. So this is one idea of how animals are able to do this, some of the mechanisms. Also, there's this thing called the polymorphic rule. So this is that category membership is based upon a certain number of relevant features. So, for example, you need multiple features. So you can't just say it's a chair because you can sit on it. Okay, you can sit on a log, you can sit on the floor. that doesn't make it a chair. So the polymorphic rule means that it has to be multiple features. So it has to have 4 legs, has to be elevated off the ground. You have to be able to sit on it. Maybe you need a back, that kind of thing. Those are multiple features that make it a category member. Okay. But again, these would all be common elements. Now, there are other higher level concepts that could be going on as well, such as natural versus artificial objects. So a natural object, so like person, a flower, whereas an artificial object would be a car or chair. And what we see is that learning artificial objects actually take longer in animals, but they do respond correctly. So they do learn. It just takes a little bit longer. So it takes longer for, say, pigeons to learn the difference between chairs and tables than it does for them to learn the difference between trees and flowers. Okay, because it's biological. Trees and flowers are a natural thing, natural relevance to a pigeon, whereas chairs and tables are not. Now, there's also abstract concepts, so same versus different. But you guys get it. So let's move on to our final topic, which will be language learning. So, is there a difference between language and communication? This is a really big debate in the research world. So to what extent does animal communication resemble language? So when we're talking about language, we're talking about humans. So the most important intellectual capacity possessed by humans is language. Animals, non-human animals, we say do not have language, they have communication. There's a whole debate, we're not going to get into it. But in language, then we can live in large social groups because of it. We're able to teach skills and information to others. We're able to express our feelings and thoughts. Now, the question is, of course, then, well, if animals don't have language, just communication, can we teach them language? This communication may help facilitate learning. Now, of course, there's other forms of human communication, like written language, sign language and braille, body language, road signs, gestures. Those are all different types of communication, and some of them may be language, but some are not. So what dictates language? So language is not just communication. There is some symbolic meaning in it. There's semantic meaning. There has to be some grammar and syntax, and then there's a critical period of acquisition of language. So, language abilities. Why are humans able to do language while others are not? Well, one reason why may be just how our anatomy, or why we aren't able to teach orangutans, chimps, and gorillas to speak English. And the reason why we're not able to teach them to speak English or even other languages that people have tried is the failure due to the vocal tract constraints. So here, then you can see this is human, this is a gorilla. We both have a tongue, of course. We have lips. We both have a palate, so that's this top thing, which is great, and we both have a nasal cavity. You can see that the human nasal cavity is bigger, but we both have one. And we both have this little thing here, the epiglottis, but ours is much further down, so that may affect it. And then the larynx. Now, the larynx is what we call the vocal cords. And here you can see our larynx, the human larynx, is larger, and it kind of takes up the entire area here. So all the air has to pass through it. Whereas in the gorilla, the larynx is much smaller, and it does not take up the entire area available, okay? So there's not a lot of support for animals possessing an intellectual skill similar to language, but we can't obviously conclude this, right? Because really, intelligence is like a human concept that we just came up with and is very debatable. But rather, there's many attempts that have been made to teach them some sort of artificial language. So what is artificial language, and how can we teach that? An artificial language is something other than verbal language. So we've got American Sign Language is what we call technically an artificial language. But we do have, I'm probably going to say it wrong, but cheerings, which is similar to a phoneme in verbal language, which is one gesture. Okay, so it's made up of small subunits. So we are able, to some degree, teach sign language to non-human subjects. So for example, a great example is there was a primate, Kanzi, who actually was able to produce a sophisticated sentence comprehension when training finished using sign language. And then there's another one, Washu, here, who was able to learn 180 different creamies or gestures to produce and make sentences. So was able to make the sentences like water bird, baby in my drink, stuff like that. So now there was Washu, who was able to learn a lot of these gestures and communicate. When her baby died, then they introduced this young 10-month-old gorilla, Lulis, who was not taught sign language by humans. However, Washu, his adoptive mom, actually did teach him signs. So they would communicate via sign language because Washu had learned it. So it was very interesting and really cool. Now, other than sign language, there are other artificial languages. So like plastic tokens. So plastic objects in varying shape, size, color, and texture represent different things. You might have been able, might have seen there's some videos online of dogs and cats where there's like these buttons on the ground and each button represents a different word or sentence, and it seems like the animals are talking to their owners by pressing these different buttons. That would be an example of using, say, plastic tokens, where each button has a different meaning, and so it's varying in the shape, size, color, and texture. There's also lexicograms, so those are symbols that serve as words. So for example, when you're doing your laundry, then there's some lexicograms on there telling you what different things mean, but we can also create lexicons to mean multiple things. And then there's spoken English. So Kanzi, one of the monkeys that was studied was actually able to learn a little bit of spoken English. Now they were able to obviously understand English, but saying the words, it was very broken. It sounded like you said, take the potato outdoors, but it was very broken. It doesn't really make sense, but, you know, it's something. There are examples of language in other species, in dogs and parrots, for example. Parrots, obviously, they do have the right anatomy to create words. In dogs, then they will respond to spoken commands, and they can actually fetch particular items. So if you say, they can be taught, say, fetch, I don't know, ball versus fetch shoe versus fetch bowl. Like, they can learn words. In dolphins, then that's what this example is here. They can learn gestures, so they behave certain ways according to a sequence of signals. So based on the sequence of what she does, it's going to mean different things. Now the question is then, of course, is proto-language really language? So this proto-language is like the artificial language or like these early languages. So there's difficulties with true grammar. So in some non-human primates like Nim and Kanzi, then there is evidence that while they were able to learn words and it seemed like they were able to learn sentences, they had trouble with grammar. So Nim, for example, was stuck on a 4-sign combination. So once you put 4 things together, he couldn't do more than that. Whereas with Kanzi, he was able to do a little better, but still not great. It's very difficult to analyze. And then we have problems with definitions. So how do we define things? Some great apes are capable of declarative lexigram use. So like sometimes they're able to like say or sign strawberry after eating it, but they won't necessarily know the word or signal for it to request it. And then, of course, there's no evidence for complex sentences. Now, songbird vocal learning is the closest ecological relative to human language in learning, and that's because in songbirds, so such as chickadees who I work with, then they do have to learn their language from a model species or a model animal. So like they will mimic their parents to learn different vocalizations. So just like humans, they start with babbling, and then we start to mimic people around us, and that's how we learn to speak. Songbirds do very similar. Songbirds have a large repertoire of songs and calls that mean different things and are used in different contexts. So it's the most complex communication system that there is in the animal kingdom, and there is some evidence that some songbirds actually do use syntax, but most of them don't. So it is the closest relative to human language, and that's why I study songbird vocal communication, to kind of understand what's happening in language learning, language acquisition, stuff like that, because it can be really hard to study in humans. So that's really all I've got for cognition, guys. Instead of my usual summary slide, I have this fun quote from Charles Darwin. He said, "Nevertheless, the difference in mind between man and the higher animals, great as it is, certainly is one of degree and not of kind." He's pretty much saying, like, even though humans are very different, it doesn't mean that we should discount the animal kingdom. That we can't just say humans are the greatest and stuff like that. That's all I've got for chapter 13. Don't forget about the final exam. I will be posting a PowerPoint review for you all that goes chapter by chapter, just a couple of the really major points. Of course, everything is fair game. And I'll also include specific details about the final, like the question breakdown, how long you'll have, maybe some questions to expect, that kind of thing. So as always, there's office hours today at 4 p.m., Thursday the 17th. The link is in the announcements. And if you have questions or can't make it, please send me an email and we can either exchange emails or set up a meeting that works for you.